Hi, my name is Tamila Chkadua. I'm a student of a Fuel Cell University, and the program is Master of Science in Business Intelligence. The course Enterprise Data Management, and based on our assignment, I'm making a small presentation of a dimensional modeling. Let's move to the slide number 1, which is we have to describe 4 steps of dimensional design process. As it is clear, there are 4 steps of dimensional design process, such as select the business process, declare the grain, identify the dimensions, identify the facts. And before the launching dimensional model, the team management must understand their needs of their businesses. Why we need it for? Because with one click you have ability to be informed with all kind of information you have launched in your database system. Also, you can use any process that business is interested in, such as number of credit card holders, online shopping sales transactions, the core reward card users total, and a lot more. I would like to use an example and present it in the table, the pharmacy sales, as a first step of dimensional design process, and then continue with the following steps. I, Tamila Chkadua, am the employee of the pharmacy and charging John for 1 Tylenol, 2 toothpaste, and 1 vitamin C at the Jimmy's Pharmacy, number 5, on Monday, February 12, 2013, in New York, New York. These activities performed by the organizations, it could be taking an order, registering the students for a class, and it's. In this small example, organization is interested in its sales at the pharmacy number 5. So that's why we have a table here. Here is the item, quantity, sales, customer, employee, store, and date. That's the information which was selected by the employee that they would need it. We don't need any information which is not necessary and which you won't need it. Let's move to the second one, the step number 2, which is declare the grain. The grain establishes rows and tables. Different grains must not be mixed in the same fact tables. This step is depending on the volume of the transaction level data. It is suggested to start with the finest grain of the data and to store them in a transactional line. Step number 3, identify the dimensions. In this step, you are identifying details which were made in each transaction and creating new dimensional tables for them. For example, store dimension, product dimension, customer dimension, employee dimension, and date dimension. In a store dimension, you have just information about the store. In a product dimension, you have as much information as much you need of a product. The same with the customer. You can add, for example, the customer's age, customer's billing address. I mean, any information, but mostly you pick the one wherever is needed for the business process. Let's move to the step number 4, which is identify the fact. This is the step in the dimensional modeling process which explains how single fact table row has one-to-one relationship to the measures, sales quantity, and how they belong to the fact tables. all these 5 dimensions, such as customer dimension, store, product data, and employee, are connected and presented through the fact table, and each measure should have foreign key that reference dimensions. For example, in a top light blue table, here is a retail sales factor. As you see, we have the information such as date key, store key, product key, customer key, employee key, quantity, and sales amount. And that's the information which was gathered from all these 5 dimensions and connected and presented through the fact table. Let's talk about the basic fact tables a little bit. The fact table is consisting of the fact of the business process, and it is at the center of the star schema or snowflake schema, which is surrounded by the dimensional tables. As you see on the visualization number 2, in the middle you have a fact table which is surrounded by the dimensional tables. There are 4 steps to designing fact tables. So in the first step, choosing the business process. In this step, is to find out what business process to model by collecting and understanding business needs and valuable data. Declare the grain. This is the step in describing what fact table should be presented. Third one, choose the dimension. In this step, we have to determine dimension for the fact tables. And the final one, it needs to be very careful in order to appear in the fact tables. Let's move to the next slide, which is OLAP cubes and other alternatives. What is the OLAP cube? Online analytical processing. And it is computing method that allows to the users very easily, quickly, and selectively extract and query data in order to analyze. It is technology that enables analysts to extract and view business data from the different point of view. It is a structure of the fast analysis. For example, if you would like to have a sales amount by time, by product, and compare them quickly and gather insights on sales results, then OLAP Cube is a perfect choice to do so. Here today I have presented a small visualization of an OLAP Cube. And based on this visualization, I would like to do at least 2 examples. For example, if we want to find out what's the black closing sale in 2010. So we go to the row to the black, then we choose the closing, and 2010 is the first row, so it means it's 977. So answer is 977. That's how this process works. Let's take another example. Silver sales in accessories category in 2010. And answer is 629. Because in the 2010 and the accessories and the silver, it crosses to right to the number 629. There were different types of OLAPs. Such as roll-up, mall-up, hole-up, and others. Roll-up relation OLAP is extended RDBMS with multi-dimensional data mapping to perform the standard relation operation. The MOLAP, it implements operational and multi-dimensional data. HOLAP, hybrid online analytical processing. In this approach, the aggregated totals are stored in a multidimensional database, while the detailed data is placed in a relational database. In others, there are several OLAPs too, such as desktop OLAP, DOLAP, web OLAP, mobile OLAP, and spiral OLAP. Let's talk now about the star schemas. Data warehouse and data marts are usually based on the star schemas, and their subjects are either facts or dimension star schemas are deployed in a relational database as a dimensional structure. They consist of fact tables that are connected to the specific dimensional tables by foreign key relationship. Here is an example how I have provided relationship, which would be shown through the system too. Each dimensional table presents its process, and through the foreign key, it's connected with the fact table. Let's see. For example, we have here the customer key, customer dimension. We're trying to connect customer key to from the retail sales fact to the customer key. Let's move to the data dimension. As you see here on the first row, there is a data key which is connected to the data key from the retail sales fact. And same is continuing with the other dimensions too. So my presentation has been ended, and I would like to add that here are the references on the last page based on what I made my presentation. So thank you very much and have a wonderful day. Bye.